So we're on quote unquote page 3. Sorry about that. No page numbers. We're at the top of it. And what I really suggest is, because they're going to give you all sorts of different things, they're letting you know the position is boom. Here's my position. It says using a calculator, when is the particle moving to the left? How do I know that I am moving to the left? Oh, if my velocity is negative, or my velocity is negative. If you're more of a words person, write that. If you're more of a symbols person, write that. Either one of those. How would I get velocity? We get to use our calculator, you guys. How would I get my velocity? Yeah. Can I just let my calculator find that derivative? Yeah, let's let my calculator do it, you guys. Let's all go to y equals. Let's go to math 8. I'm going to go type in 1/3, x to the third. We're going to say minus 5/2, x to the second. And then minus plus 4t plus 6. And again, this is a little funky. What are we going to say for when x equals what? I want the whole derivative. So you guys, we always say when x equals x. I don't want the derivative at a certain moment. I want the whole derivative. So we're going to say when... Oh, girl, you just saved me. Thank you. Margie, do you want a warhead? So let's sketch this, you guys. Does not need to be perfect. All I'm going to do is I'm going to be like, okay, it looks a little something like this. Just a little sketch. It's going to mess with us. What did we just graph? Position, velocity, or acceleration? We just graphed the velocity. This is a velocity graph. So if I were to say, hey, at this moment, if I were to look at this point, that would tell me the velocity at that moment in time. This would tell me the velocity at this moment. The velocity, the velocity, the velocity, because it's a velocity graph. What if I looked at the slope of a velocity graph? That's going to be acceleration. So I'm just looking at points. You guys, right here, what are all these y values? Positive. Do you agree on this velocity graph, all of these y values, all of these points, if I were to list these points, the y coordinates would be positive? What about these y coordinates? I'm going to put them in black. Negative. What about these y coordinates? Negative. What about these y coordinates? Negative. Isn't everything underneath the y-axis? If you were to tell me that point, this would be like 6, -4, 7, -3, 8, -2, something like that. You agree that everything down here is negative. What about when I go back up here? What are all these y values? These are all positive. So when the velocity is positive, meaning my particle would be moving to the right, would be anything up here. When is my particle moving to the left? It's when it hasn't, you guys told me, when my velocity is negative. We're looking for these values. I'll never forget Molly Smith. I don't know if that name rings a bell to you. Molly Smith, Matthew Smith. They live on Cambridge, question mark? Yeah. Arlington. They have a pool, right? Okay. She would always do this. Just to remind yourself, anything down here is negative because we want to say, like, over here, the slope is positive. I agree, but I'm asking for the values. Especially on this one, check this out. They're saying, hey, I only care about my t's from 0. So that's talking about from here until 5. I'm not quite sure where that is. But to your point, they don't care about negative time. Okay? So you guys, what can we use our calculator for to figure out when my velocity is negative, what these values are with that? How did I figure that out? What option in my calculator? Didn't want the clock. I want this. Trace would get me close, but it's not going to get me exact. How would I figure out what this value is? When my y values went from positive to negative, what do they have to cross through? Yeah, which is when my y values are positive, my y values are negative, they have to go through the y value of 0. What about over here? Same thing. So you guys, that's when we're going to just do second trace. Option 2 is find the 0. That's going to find me that x-intercept. I believe on yours we've got to go left bound. So I'm going to go to the left of that 0. I'm going to press the right arrow to go to the right. And I'm going to get a 0 of t equals, in this case, what did you guys get? I got 1. T equals 1? We got to do the same thing. So if you did not get t as 1, just hang with me right here. Ready? We're all going to go do second trace. Option 2. And now I'm going to go to my other 0. My other 0 is over here. I need to get to the left of it, and I'm going to hit enter. I'm going to use my right arrow to go to the right of it and hit enter. You'll just hit enter one more time. Who cares about the guess? And we'll get another t value. What did you get for that one? Yeah, the chances that it's a whole number is pretty nice. It's not always going to be that. So it's saying that the x value here was 1 and here was 4. And every x value in between, I had negative y values. Therefore, my velocity was negative. So, Then, yesterday we talked about speeding up and slowing down. Okay, Ellie brings up a good point. When is it to the left, moving to the left? I just said, yeah. You guys, we should say from 1 to 4. 2 different ways to write this. Like that, or this is going to start messing us up a little bit. Like this. Ugh, who does not like this? I understand why. Because doesn't this look like a coordinate? X comma y. This is called interval notation. We're going to see a lot of that this year. Meaning, it says, when is the particle moving towards the left? This is saying from an x value of 1 to an x value of 4. I do want to also tell you, if you were to say or equal to's here and make these brackets, bless you, AP does not care one way or the other. We're good either way. Okay? Yeah, for my last warhead. Speeding up or slowing down. We talked about this a smidge yesterday. How do I know if something's speeding up or slowing down? Does anyone remember? Has to do with the velocity and the acceleration. Yeah, Jay. Then they are doing what? Nice. So if they're speeding up, my velocity and acceleration have the same sign. Either they're both positive or they're both negative. It means that it's speeding up. If they're slowing down, my velocity is positive, my acceleration is negative, or vice versa. We will write that down as our justification as soon as we figure out what they are. So they said at t is 3. You guys, we need to go find my velocities, my velocity at 3 and my acceleration. If they gave us position here, how would I write my velocity if I were to do that by hand? Awesome, it'd be x prime. So let's just write x prime at t. X prime at 3. You do not need to do this by hand. I'm going to let the calculator do the whole thing. And then if I need my acceleration, and maybe we just write ourselves a note, that's going to be our velocity at t is 3. This is not necessary. I just figure in the beginning it might help some people. How would I say acceleration if x prime is velocity? Love it, curve. X double prime at 3 will get me my acceleration at 3. Again, this highlighted part is not necessary, just maybe helpful right now. Let's let our calculator do the work. Let's go to, real fast, I'm going to show you 2 different ways to do this. What graph are we looking at right here? Velocity. You guys, we want the velocity when t is 3. How do you think I could use my calculator to do that for me? Trace, then what? Just type in 3. Trace, 3, enter. Did they give you a y value? What is it? -2? Yeah, agreed. Thanks, buddy. Oh gosh, I put that in the wrong spot. -2. Now, let's go out to that home screen because I want to just show you one way to do it. We could always do, and actually you don't need to type this out. Let me type this out for you because you don't need to retype all this on the home screen. 1/3 x cubed minus 5/2 x squared, and then plus 4x plus 6. And I want to know the derivative when x is 3. Boom. I don't know what's up with my rounding error on this free calculator, but you agree it's -2? So we could have gotten it that way as well. What do we need to do now to get x double prime of 3? Yeah, we got to go find x double prime, don't you think? Or at least x prime and let it take the derivative of x double prime. Let's do it. Let's go find x prime of t, you guys. X prime of t, we did this yesterday, actually. What's the 1/3 times 3 going to do? Yeah, it's just t squared minus 5t plus. Beautiful. That's my velocity. Can we type in math 8 of that to get my acceleration? Yeah, let's go do that. Math 8, I'm going to say of x squared minus 5x plus 4. When do we want the acceleration? At x is 3. Very good, you guys. I got 1. Anyone else get 1? Word. Okay. Hey, J-Bro, look at these signs. 1's negative, my velocity's negative, my acceleration's positive. Therefore, speeding up or slowing down. Slowing down. And this is how we say it. The justification. We're going to say slowing down because velocity and acceleration, or you could have said x prime of 3 and x double prime of 3, however you want to say, have opposite signs. And the key is letting us know when at t equals 3. I just gave a little Sophia Sabo Ramsey a little shout out here. 50-minute training on a training run to prepare for upcoming marathon. And then this is, again, important. Her velocity is given. I think it's important to note that. Her velocity is given. Some info about it, right? Just her velocity at certain moments in time. Estimate her acceleration when t is 10. So you guys, we've done this 200 times. Ev, you okay, Bubba? Okay, we've done this 200 times. We just haven't had used the words with it. I've said, hey, this was v. I said this is x prime, and I said go find x double prime. But now we just have words with it. This is the velocity. How would I find acceleration when t is 10? Changing y over changing x is just the slope, right? If I've got velocity, the acceleration's the next derivative. How would we write my final answer? Don't you be simplifying, people. What minus what over what minus what?
220 minus 170.
Love it.
Over 15 minus 5.
Beautiful. Look what they said right here. That's going to get us an extra point. So meters per minute was my y. And then we got to put it over my x, right? So we're going to say meters per minute or per minute squared. Either one. Whenever we're looking for acceleration, we will always have the squared under it. Hey, this is kind of a hint because it's like acceleration is the second derivative. A little squared there, you know what I'm saying? Okay, question. Must Sophia have switched directions, like turned around anywhere during her training? So she was like, oh, I'm running so fast. Oh my gosh. Actually, I'm running on a track. So I'm going forward and then I'm going backward. And then I'm going forward and then I'm going backward. What would happen to your velocity if you're going left, then you're going right? To positive, right? So my sign has to change. My velocity has to change signs, and that's how we're going to say it. Does it say explain why or why not? Does my velocity change signs, do we think? What did they give us in this table? Oh, they gave us velocity. Okay. Do you think that it ever changed signs? From 0 to 170, did it have to change signs? Could it have stayed positive? Yeah. Could it have changed signs? Maybe. But it says, did she have to? What about from 170 to 220? Not necessarily. 220 to negative 230? Ooh. So she changed signs, changed direction somewhere in there. Anywhere else? Yeah. Yep. What would be my two regions? From what time to what time would she have had to have changed signs?
15 to 32.
Awesome. This is where we're going to do that interval notation again, people. We're going to say, okay, from 15 to 32. Row. If you put some brackets on there, you cool, you Gucci. If Ellie writes it as 15 to T to 32, we good. And if Elise throws some or equal to's there, we good. Whichever. But their answer is probably going to be in this notation, so I just want us to get used to that. Anywhere else that we had to have changed signs sometime, changed directions? 40 to 50. 40 to 50. What's my y? We do not need novels. What happened? What were these units? I'm sorry, what was this called? These were her v of t's, right? Her velocity. Because we can just say because v of t did what? Say it again.
I said it went negative.
Yeah. Or if we go from positive to negative or negative to positive, it's just called changing signs or switching signs because v of t changed signs. That's all I'm going to say. That's all they need. Now, Beck, we could totally say, my V of t went from positive to negative, and then from negative to positive. You can totally say that. But if you want to write less, well, they're good with just changing signs. Yeah, and I think that's really important to note. The velocity is shown. The velocity is shown. I think this is going to help put things into real world for us.
Don't you all?
Guys, you are well trained. Thank you. That was great. Okay, what do we think the ant is doing? Let's kind of start it off. This is the velocity. This is the velocity. Okay, let's just answer me this. What is the ant's velocity? This is just random. At t equals 2.5, what do we got here? Minutes? Seconds. What is its velocity at 2.5 seconds-ish? I'm not looking for anything great. 2 centimeters per second. You're saying it's just kind of at 2.5 seconds, you were just reading that y value, right? Because it's a velocity graph. I'd say 2 centimeters per second is great. What's the ant's velocity at t equals 4? Yeah. The ant is going, it stopped, right? What is the ant doing then at t equals 4? It's staying still because the velocity was 0 really quick. What was it doing before? What was my velocity before? What was it before? My velocity was decreasing. Which direction was he going? To the right. My velocity is 0. Then what does he do? Turns around. What is he doing then? Ooh, he's getting faster. Then what's he doing? Is he still going to the left? Is this a mind mess? Because you're like, what? It's going. Everything underneath the velocity is 0. I mean, is negative. Everything above my velocity is positive. So everything above, he's moving to the right. Everything below, he's moving to the left. That was cute, Meister. Thanks for your So, okay, you guys. So let's talk about the beginning. Oh boy, let's talk about the beginning. What's my little ant doing here? If the velocity is increasing, where is it going though? To the right, because my velocity was positive. So you guys, we're gonna say it's moving to the right on what interval? From what time to what time is it moving to the right? Yes, Kendall. Oh my gosh, I think this is a really hard one. From 0 to 4. Guys, we can go brackets or parentheses. I might just go parentheses. 0 to 4. How did she know that? Because that's every time my velocity was positive. Okay. Then I break it down a little bit. What about just from 0 to 2? What do you think I'm trying? The velocity of the ant is doing what? It is increasing. My velocity is getting bigger. This is 1 centimeter per second. This is 2 centimeters per second. So I'm going to go ahead and say it's increasing here. What about between 2 and 3? What is my velocity doing? It's constant, you guys. He's cruising at 2 centimeters a second. For an ant, I'd say that's kind of fast. Between 3 and 4. My velocity is approaching what number? My velocity is approaching 0. Therefore, what's my cute little ant doing? Slowing down. I love it. The velocity is slowing down or decreasing. I might say decreasing, whatevs. Same diff. Decreasing. And then I said, but the ant is still moving to the right. We agree with that. To me, that's a mind mess. Moving to the right, getting faster, staying constant, moving slower, all to the right. Then I said at 4, the ant does what? Stops briefly, just for one quick little moment in time. Then what does he do? Turns around, then does what? Starts walking to the, beautiful, you guys. Turns around, starts walking to the left. The velocity of the ant, this is hard, between 4 and 5 is doing what? It is increasing. You guys, people have a hard time seeing that because they're like, wait, it's going more negative. I agree. It's just letting you know it's going faster to the left. Because here he's going 2 centimeters per second just to the left. So we're going to say it is increasing. You could say INC. AP is okay with that too. In the what direction? We would just, yeah, left or negative. Either way, I'm good with it. Between 5 and 7, where's the ant walking?
Left.
Still left. What's its velocity doing? It's decreasing because he's getting closer to 0, right? So we're going to say walks to the left, but the velocity is decreasing, slowing down, whatever you want to say. I'm Gucci. This is the last one for the day. Here we go. We got another particle. Ooh, what did I give you? Velocity. So I'm just going to remind myself, that's a velocity graph. When is the particle moving to the right? Say it. 0 to 1. Again, it's a mind mess. You're like, what? This literally is going down. I agree. My velocity started how fast, you guys? How fast was this thing starting at t equals 0? 50. I didn't even give you any units. Sorry about that. 50, let's say, feet per second. And then it approaches 0 feet per second. So we're moving to the right from 0 to 1. Agreed. Anywhere else?
I'd say 6 to 7.
Where else?
5 to 7.
Yeah, very good. Anything above, very good. Okay? When am I moving to the left? To the left, to the left.
1 to 5.
Agreed. Left just means I have negative velocity. Anything under that x-axis, we got 1 to 5 there. Boop. Ooh, talking about that speeding up. Speeding up just means my velocity increases. When does my velocity get bigger?
1 to 2.5.
Yeah, I love that. So my...
Straight here.
Yeah, this is straight. Sorry, so that meant to be a constant. Yeah, I love it. So you're saying my velocity is getting bigger in just in the negative direction. Who cares? It's just going to the left, but it's going 10 centimeters per second, 20, 30, 40, 50. So from 1 to 2, I love that. Anywhere else? Yes. Anytime we're going away from 0 is really when it's speeding up. So 5 to 6, anywhere else? I agree. Slowing down. If I'm slowing down, that just means that my velocity is approaching 0. 0 to 1, my velocity approaches 0. From 0 to 1. 3 to 5. 6 to 7. Guys, this is good. Okay. Acceleration. Math, this might help. Acceleration. How would I get acceleration from a velocity graph?
Derivative.
Derivative, which is just fancy word for slope. Could I look at the slope of this thing? When is the particle's acceleration positive? That just means that the derivative of velocity or the slope of velocity has to be positive. What would you say the slope of velocity is here? Negative. What's the slope of velocity here? What's the slope of velocity here? And here. Woo! So what would we say? When is my acceleration going to be positive? 3 to 6. Good job, you guys. Acceleration negative is going to be when the slope of my velocity graph is negative. What are we looking at here?
0 to 2.
And here, I love it. 0 to 2. Anywhere else? Beautiful. 6 to 7. 0 to 2. Particles acceleration 0. Yeah, 2 to 3. Again, the slope of velocity was 0 there from 2 to 3. Oh, and 7 to 9. Awesome. Oh, when does the particle move at its greatest speed? I didn't care about direction.
0.
At 0. Agreed. It's going 50 somethings. I don't know what those units are, but at t equals 0. Where else? And isn't it also going 50 somethings? I'm sorry, your graph is terrible. 1, 2, 3, 4, 5. There's supposed to be a tick mark there. It's supposed to be negative 50 is the velocity there. Sorry about that. Boop. Negative 50. Yes, so we're going to say from 2 to 3 as well. It's still going 50 blanks per second. When does my cute little particle stand still? If I stand still, if I'm at rest, what do I know? My what 0? Thanks. My velocity is 0. So maybe you write yourself a little note. My velocity is 0. When is my velocity 0?
2 to 3.
Close. Isn't acceleration 0 there?
1.
Ooh, at 1.
7 to
Oh, but look what I said. This kind of goes back to Ro's question. For more than an instant. So just 7 to 9. Ro, to your point, 1 is just a blink in time, right? I agree. The velocity is 0 there, but just for the slightest moment. But from 7 to 9, he's chilling. Love it. And maybe you're saying like, ooh, more than an instant. That was what she clarified. What is the speed of the particle? What is the speed at t equals 2 seconds. Speed. When the police officer clocks you, is he saying you're going negative 50 miles an hour? No, you're just going to say 50, yeah, units per whatever.